Hello, good morning friends. Today I'd like to continue electric field. So now, what do you mean by electric field? In the previous class we learned regarding electric charges. So charges which produces magnetic and electric properties. Right? So if the charge is present, either it is a positive charge or if it is a negative charge. I said to you, when two similar charges are there, they'll attract each other. And if two similar charges are there, they will repel each other. So why this happens? Because if any charge is present, around that charge, some force will be developed. Okay, electric field is like it creates its own field around the space, in the space itself, around itself, in the space, it creates one electric field. Means it is having the capacity to attract or repel some other charges. So in the presence of air or space, it will create its own field. Okay, if it is a positive charge, what happens? That positive charge will from the positive charge, always the direction of electric field is outwards. The lines of force is always outwards from the positive charge, because the field originate from the positive charge and it terminates at a negative charge. Suppose I have taken one diagram here. Here I have considered one positive charge plus Q. Okay, around that positive plus Q charge, I have taken imaginary lines. These are imaginary lines. If field is created around the charge, the field will be like this. Imaginary line it is. So here, always from the positive charge, the field force originate from positive charge. So only I have given outward direction. See, charges are originating from here. Okay, if I take negative charge, see, the direction of field is coming like this towards the negative charge. So arrow you have to see, this is outwards, this is inwards. For negative charge it is inwards. For positive charge it is outwards. Direction is important for the charges. So for positive it is outward, for negative it is inward. So what do you mean by electric field? Electric field is every charge creates an electric field in the space itself. See, this is one charge and this is one charge. See, this is a negative charge. It creates its own field. Means force. Suppose I'll tell you example. Here Q naught. Q naught means Q naught is a test charge to test whether field is there in the presence of this or not. Suppose I'll give you one example. While watching your TV, okay, suddenly if the power has gone, okay, stand in front of your TV. So actually, if you are standing in front of your TV, the airs on your body, like airs on your hand, will be attracted towards the TV, isn't it? So why? Because electric field influence will be there around the TV. Even though power has gone off, when you stand there nearly, the air will get attracted. If you are standing, if you are keeping your hand near the TV, that airs will be attracted towards the TV. Why? Because TV has created some external field around it. Okay, so in the same way, charges will create its own field around itself, and this is an imaginary field. And here from the positive charge it is outwards, radially outwards, and it is for the negative charge it is radially inwards. And coming here, plus Q naught, take one test charge. Okay, for example, keep the test charge somewhere here, where the electric field is not present. So this positive charge Q naught test charge will not attracted or repelled by this positive charge because it is outside from the field. Okay, if I keep this Q naught charge suppose here, then it is in the electric field. Plus Q has created its field, right? In the field I'll keep here somewhere here. Then what happens, that Q naught will be, if it is a positive charge, test charge is always positive. Q naught value is always positive because to test we are taking, no, this is always positive charge. This is positive charge and this is positive charge. What happens? Repulsion arises in between positive charge and Q naught. Q naught you have to place here in the field, in the presence of the field you have to place. Then positive, they'll repel each other. If somewhere here the charge is present, suppose here another one more negative charge you placed here, somewhere here, so positive, negative, this positive charge attracts this towards him. Why? Because I'm telling this, so if you are keeping the charge somewhere and if you are telling another charge is somewhere far away from the charge, then they don't experience Coulombic force. If they have to apply Coulombic force, they should be within the certain range. Okay, then only they can exert force on each other. Okay, here I said test charge is positive charge. For the positive charge, the direction of force is radially outwards because field arises from positive charge. Okay, and here for the positive charge, field is away from the plus Q because field will be in this direction, because here positive charge is there, here positive charge is there, positive repulsion will arise. Here negative charge is there. Here test charge you have to take plus Q naught, it is. Test charge means positive charge. Here positive, here negative. They'll attract each other. If you are passing out of the space, out of the electric field, they won't experience any force. If you are bringing this Q naught here, somewhere here, and minus Q is here, and you are keeping this plus Q naught here, plus minus, they'll attract each other, isn't it? So this is the field. Inside the field, if you are keeping any other charge, so due to the presence of charges, either it may be a similar charges or another charges, unsimilar charges. If it is the same charges, they will repel each other. If it is unsimilar charges, they will attract each other. And for the negative charge, field is outwards. Sorry, field is inwards. For positive charge, it is outwards. For negative charge, the direction is inward. Okay. And here I have written for negative charge radially inwards. E is a vector quantity. Electric field is a vector quantity because it has magnitude as well as direction. See, I am showing the direction for positive charge outside. For negative charge, I am showing the direction inwards. So we have this direction also with the magnitude. So electric field is a vector quantity. And okay, fine, madam, if negative charge or positive charge is there, it will create its own field. Okay, fine. If we place the test charge here on the negative charge, it will attract. If we keep this positive test charge here, it will repel each other. Okay, then what about this Q naught? Whether Q naught will create its own field or not? The answer is no. Why? Because this is a test charge. Q naught is a test charge and this is a positive charge. Q naught value is always we are considering plus 1. Plus 1, very small number it is, plus 1. So Q naught is a test charge. Q naught value we are considering always 1 and this is a positive charge, and this which does not create its field because it is very small, that is equal to 1. So if in the case plus Q naught creates its own field and our charges creates positive or negative charges, they creates its own field. What happens? It doesn't come here because it has its own field and it has its own field. So it is not possible like that. So Q naught is the test charge and it is a very very small. It does not create any field around itself. So only we can place this test charge near the negative charge and near the positive charge. If it is near the positive charge, it is repelled by the positive charge. If it is near to negative charge, it is attracted towards the negative charge because the sign of the test charge is positive. Coming here, intensity of electric field due to a point charge plus Q at a distance r from it. So we are finding electric field intensity due to a point charge. Point charge means again test charge. Okay, now consider this is the line. Okay, and here I have taken one positive charge plus Q placed here. Okay, and I have taken on this line somewhere here I have placed Q naught test charge. Okay, I said just now Q naught is always positive and Q naught value we have to consider very very small value, that is starting value. Q naught is equal to plus 1 I have taken. And where I have situated this Q naught at a place P. Okay, now here understand this is a positive charge. Even our Q naught is a positive charge. Its value is plus 1. This is plus Q, this is plus 1. Plus Q plus plus plus. Similar charge. So they will repel each other. Then the field is outwards like this. Here positive charge is there, here positive charge is there. Repulsion will arise. The electric field will be outside from these two charges like this. In this way it will arise. So now we know the formula for electric field. What is the formula? Electric field is equal to force on the test charge by test charge. Force on the test charge is how much? 1 by 4 pi epsilon naught q1 q2 by r square, or I can say 1 by 4 pi epsilon naught value is equal to k we are taking. Now come here, then electric field at point P is equal to force on the test charge. How much? K into Q1 into Q2 by R square. Test charge is what? Q naught divided by Q naught. Come here, Q1 is how much here? Plus Q. Q2 is how much here? Q naught. So it becomes K into Q naught by R square whole divided by Q naught. Here one Q naught is there. Downside one more Q naught is there. They will cancel each other. What is remaining? KQ by R square is remaining. Now electric field. Okay. Electric field due to the positive charge at a distance r, the equation comes out to be KQ by R square. Okay. So what is electric field intensity? Electric field intensity means force experienced for unit charge. That is only I have given here. E is equal to force on test charge by test charge. Force experienced for unit charge is called as the electric field intensity. Strength is it is. Strength. Field intensity means what? Strength. Okay. So we will continue in the next class. Thank you. Please subscribe to this channel to get more videos.